Okay, hello everybody. Good afternoon. Happy Wednesday. I am off with the math department, and we are doing some professional development today. The entire math department. So I'm sure you can anticipate how much fun that is as we all sit around and crunch numbers. But anyway, I want to show you how to do what's called the composition of functions. And in order to hopefully give you enough information to work on these problems, I'm going to go over problem 1, which is part of the example problems. And then we'll go down to your assignment and we'll do number 4 together. And then the last one we'll do is we'll do number 2. And if you notice, number 2 is a little different than the previous two because we've got an actual number right here. These are actually the easier of the two processes I'm going to show you. So let's go ahead and start out with the harder ones where we have this letter right here. Okay? So if you look at number 1, we have function f, which is 3n plus 2. We have function g, which is negative 2n minus 1. And then down here we've got this notation that says find f, and this is actually an open circle. Okay, so it looks kind of like the word fog, but it's not the word fog. It's f composition g is how we read that. So that little symbol means composition. So let me write that down. So that's what that little symbol means, composition, that little open circle right there. And essentially what that means is we're going to combine these two functions. And the way we're going to combine them is we're going to take g and we're going to substitute or plug it into function f. Okay? And because it's in this order, f composition g, that means plug g into function f. And so what that means that in function f, wherever I have an n, I'm going to substitute negative 2n squared minus 1. All right, so all's composition is a substitution. You take the second function or second equation and substitute it into the first one. Now, what does that look like in a formal notation? Well, since it's g composition f, instead of writing down f of n, I'm going to write f of negative 2n squared minus 1. And so you can see I'm substituting in negative 2n squared minus 1 wherever I have an n. Right here. And so that's just kind of our notation side, if you remember. But more importantly, I got to substitute negative 2n squared minus 1 in right here. So I'm going to keep my 3, negative 2n minus a squared minus 1. That's what substitutes in. And then plus 2. So once again, just to reiterate what I did, I substituted in negative 2n squared minus 1 in for n in place right here. And I did that because it's f composition g, which means I take g and I plug it back into function f. All right, all we have to do now is we have to take all of this and we just have to clean it up and simplify it. And so in order to simplify it, we do our distributive property and we get negative 6n squared minus 3. Sorry if you heard that sigh. My dog's over there deflating for the evening. And then we got a plus 2. So he's old. He moans when he lays down. So anyway, so now we've done our distributive property with that 3. And now you can see we take the negative 3 and the 2 and we add them up together. So we get negative 6n squared minus 1. And that is our final answer. That is f composition g of n, which once again means what equation do I get when I take g and plug it into f. And you can see I took function g and I substituted it in and simplified. And here's our answer. So that's our composition. And that's essentially what composition is. Take one equation, the second one, and plug it into the first one. Okay? Well, let's take a look at another example here. So let's go to problem number 4. And you can see I've got g of n equals n squared minus n, 2n, excuse me. There we go. And 2n minus 4 is function f. Here I've got this asked me to find f composition g. So here I'm going to plug f into g. So that's what we're doing here. We're taking this one and plugging it back into that one. So that means that I'm going to start with g and I'm going to substitute whatever function f is 2n minus 4 in place of n. So now here in this one, you can see we've got a couple of n's right there and right there. So I've got to go 2n minus 4, quantity squared, so we're going to have a little magic square action, minus 2, and then 2n minus 4. So G composition F, take function F, plug it back into function G. Function F is 2n minus 4, so wherever I have up here, I have to substitute 2n minus 4 in both of these places. And now we have to go ahead and clean this up. So it's kind of a little on the side here, 2n minus 4. When we have the quantity squared, it's really that right there. Okay, so don't forget about that. So I'm going to go ahead and magic square this. If you want to just regular FOIL, that's fine also. So 2n minus 4, 2n minus 4, you get 4n squared, negative 8n, negative 8n, and positive 16. Okay, so that's plus 16 right there. Oh, that's terrible. Let me cross that out, 16. There we go. Okay, so that means that 2n minus 4, the quantity squared, is going to end up being 4n squared minus 16n plus 16. And that's where that comes from. And then we have to do the distributive property. Don't forget this is negative 2 times each of these. So minus 4n and plus 8 when we do our distributive property. And now lastly, we want to clean it up. So I have 4n squared, takes care of that term right there. Got negative 16n and negative 4n, which is negative 20n. And then 16 and 8 is 24. And so that is our, sorry about that, I was just grabbing something. And so that's our composition. And it looks like we did it correct. I'm just checking the answers. And you can see number 4 right over here on the right. We've got the correct answer. And now that is, just to get the notation down, that is G composition F of N. Right? So once again, G composition F, plug F into G. It's always the second one, plug it into the first one. So that means in function G, I'm going to substitute in 2n minus 4. And I got to do it there. And in this particular problem, I've got a magic square. And then I've also got a distributive property and then my cleanup process. So there's my composition right there. Okay? All right, lastly, let's go back to number 2. So number 2 is a little different in the fact that we have a number here. Okay? And so there's 2 ways we could go about doing it. And I'm going to show you what I think is the easier way first, and then I'll show you the other way where you end up with the same thing. So the first way, and once again, this only works if you have a number here. The first way is I can take this number 2 and first plug it into function h, get an answer, and then take my answer and plug it into function g. And so if I want to do it that way, I'm going to write this out formally. I go h of 2, first take 2, plug it into h, and I get 4 times 2 minus 5. Okay, 4 times 2 minus 5. And so I go ahead and simplify that. I get 8 minus 5, which is 3. I then take the answer I just got and I plug it into G. So I started with 2, plugged it in H, got my answer, and now I'm going to take my answer and plug it into G. And so I plug 3 into function G, and you get 3 squared minus 5 times 3. 3 squared is 9 minus 15, and we get an answer of negative 6. Let's see if that is correct. Number 2, negative 6. Whew, know what I'm doing. Okay, so that's the one way to do it. And once again, this only works if you have a number here. If you have a letter, you've got to go for the previous two examples. Right? The other way that you can do it is you can first do G composition of H if you want to. Get the composition and then plug in 2. Okay? So I'm going to do the G composition of H, which if you remember, that means I plug H into G. Okay? So I'm going to plug H into G. So I'm going to take my H, which is this right here, and I'm going to substitute it in. Oops. No, that's correct. Sorry. G of 4x minus 5. And we're going to get 4x minus 5, the quantity squared, minus 5 times 4x minus 5. And so, I'm going to do a quick magic squares here in my head, or a FOIL. We get 16x squared. We're going to get, let's see, minus 40x plus 25. And then if I distribute this, I get minus 20x plus 25. And so, if I clean this up, I get 16x squared minus 60x plus 50. And now I'd have to take this equation, assuming it's right, and I'm not sure if it is or not, and now I'd have to plug in 2. And so I get 16 times 2 squared minus 60 times 2 plus 50. And so I get 16 times 4 minus 120 plus 50. 16 times 4 is 64 minus 120 plus 50. 64 and 50 is 114 minus 120. And you can see you get an answer of negative 6. Oh, sorry, I was off the screen. Hopefully you could hear me. So you can see you end up getting the same answer, okay? But you can also see it's a lot more complicated. So I would recommend that whenever you have a number here, you take that number, first plug it into this function, get an answer, and then plug it into this function and get your final answer, okay? And that's all I got for you. Hopefully you're able to work through the problems now. So you've got the rest of these problems to work on from this sheet right here. You can check your answers as you go. You can also, if you want to, if you need more assistance, Khan Academy. And you want to search for composition. Or you can search for anything, any composition videos would work. So, all right, take care, and we'll see you Thursday. Bye now.